Hi, I'm Abraham, and I'll be presenting Team 7's presentation for the power plant for Sparkyville, why we chose a water mill versus other sources of power. For this project, there were three main sources of power presented. There was wind, water, and solar, very natural sources of power. I'm going to consider both wind and solar together. That's kind of where we started, as they have a lot in common, both positive and negative. They're very natural sources of power, which appeals to a lot of people. However, it kind of goes downhill from there, unfortunately. They're both very diffuse sources of power. The apparatus used to collect this power are very large, very expensive, unfortunately. As far as windmills and solar panels, very large. And even though the power cost is falling, it's really hard to compare that with the third option, which is water. Water, as far as a stream or a waterfall, very reliable source of flow. That coupled with the density of water. Water is a very high density liquid, and density is directly correlated to potential energy that we can tap for our power plant. And it was these considered together that we decided that a water power plant would be the most cost effective and receive the maximum amount of power. Thank you.
I am Turkey, and I'm gonna be talking about the first design we came up with. We were actually inspired by the top shelf in the classroom, and the problem with this design is the potential energy. And since this design has a large tank, there is like medium potential energy, which does not really work for what we trying to accomplish in this design. The good thing about this one is that there is a high gear ratio, and that's what we're gonna keep in the next design. Thank you so much.
So my name's David, and I'll be talking about the second design. And so as you can see, we decided to change the tank a little bit. We decided to go from a rectangular box to more of a cone shape. And there was two reasons for this. The first being is that we'd be using less materials, so that would lead to a reduced cost in using less space for our whole power plant. And also the second reason was that we thought we could gain more potential energy with this design because the average volume of the water would be higher up, which would lead to a higher potential energy. And as you can see, we still decided to keep the high gear ratio of the water wheel to the power plant. And as you can see from the side view, this is how it looks from the side, with the water wheel being here and with the generator being attached to it by a pulley system. All right, thank you.
All right, I'm going to talk about our third design. All right, so for the third design, we kind of continue with this idea of where the water is at as far as potential energy, which is height. Height is a direct function of potential energy, and that's what we're trying to harvest with a water power plant. And so with this third design, we decided to go all in and make the tank similar to the first design, but just much higher up. Gives us more average potential energy. And a part of this design is the cylinder, which the water flows directly down, allows for very clear control of the flow, and we can bring it right close to the water wheel, which leads to less splashing and less loss of energy. Similarly, we kept the high gear ratio between the water wheel and the generator. However, we moved the generator more within the structure of our power plant in order to save space, and that's just what worked here. Thank you.
Hello, I'm Joseph. I'll be talking about our final decision on our project. So we decided to go with a design that was completely different because we actually realized in our initial designs we are losing all of the kinetic energy coming out of the system as a whole. And what I'm talking about is this distance right here from the top of the ramp to the top of the spout. City limits only allow us to go up to a certain distance to that spout. And with the tank designs, the potential energy is limited by the top of the tank. Otherwise, everything else would just flood over. Now, our ramp design will actually maximize the amount of potential energy because the water is starting from a higher position, and the kinetic energy as it flows out of the pipe into our system. And the ramp here has actually got an opening as the water flows into it, and what that will allow is it will allow for flooding to shoot over where the projected distance is, and yet our ramp will still be able to harvest all of that into our system for power generation. And what that means for the system as a whole is increased power output, because it all will be funneled right here out of the ramp onto our water wheel. So in this case, flooding is actually good for the city in this one particular instance. We decided to keep the generator ratio. However, this is completely different in the sense of where the generator is located to the prior three. We decided to shoot it off to the side and attach a pulley to the water wheel. And what that pulley will do is it's actually also going to act as a counterweight to centralize the general weight of the system, so that the center of gravity is just here on this middle support. And that's going to allow for a more even rotation of the system, and it will actually allow for this wheel to almost be the size of the water wheel. We're just going to keep it a little smaller just to allow rotation without friction on the bottom. And the reasons we decided to do this in conclusion is because the final design is a huge conservation of space. The only amount that will be intruding on the given area is just that little initial amount for that generator system and the system to hold the ramp up. And the rest of it we can convert into a park, as we've just added a beautiful water feature to that park in the form of a generator. It also maximizes the amount of potential energy and kinetic energy of the system, and we're not losing anything. Furthermore, it returns the water immediately back to the river. There's no holding it, there's no man-made lakes, and it's a really good investment for Sparkyville. Thank you so much.